Good morning and welcome. Today I'm going to show you how to calculate z-scores and more importantly what they mean and where we can use them. So first things first, to understand the z-scores you need to know about standard deviation. You need to know what that means and you need to know what the mean means. Okay, so if you have a low standard deviation, like on the left, this graph here, you can see that all the scores, all the data is kind of clustered, and that gives a low standard deviation. This actually means that this data is accurate. While the figure on the right here, which shows that the data is not so clustered, it shows a number distribution with much higher standard deviation. So this one has a low standard deviation and that one has a high standard deviation. Alright, so the main thing with z-scores is to be able to compare two sets of data and to be able to say that one is more statistically accurate than the other, or maybe one has more of a strength than another. Okay, so the z-score indicates the position of a particular score in relation to the mean, right? And this is with reference to the standard deviation that's calculated for that set of data. So important things to know: z-score of 0 means that it's equal to the mean. Negative z-score means that it's below the mean, and positive z-score indicates that it's above the mean. So you need to remember those three things. Alright, so like I said, it measures the distance from the mean in terms of standard deviation. So in relation to that, a z-score that is exactly one standard deviation above the mean has a z-score of 1, and if it has 1 below the mean, has a z-score of -1. Now to calculate the z-score, that's the formula you use, where x is the score that you're trying to figure out what the z-score for that value is. Then you've got the mean of all of that data and the standard deviation. Alright, so just a summary of what I just said. The z-score will measure how far away your score is from the mean, and that will be either positive or negative. And if it's got a positive 1, that's 1 standard deviation away from the mean, and if it's a negative 1, that's 1 standard deviation away from the mean. Then most important thing really is trying to compare these z-scores. So that's where the application happens. To calculate the z-score, it's not difficult. All you've got to do is get the score that you want to compare, subtract it from the average, that's the mean, divided by the standard deviation. Alright, let's see what I mean by that. Okay, in this case, you want to compare two sets of data. Alright, so suppose that in your maths exam you got 74, alright, and in English your result was 63. Which one did you which subject did you get better at? Now the truth is that the maths exam in this case, it looks better, but it doesn't take into account that difficulty of this test. Could have been that maths was easy, right? So how do we compare these two exams? So the only way we can fairly compare these results is to get the mean, standard deviation, and then converting it into a z-score. A higher z-score will mean that that exam was more difficult, and if it was a lower z-score, that means that exam was easy. Alright, if we look at mathematics, we have been given the average of 60, we have been given the standard deviation. Now what we want to compare is that 74. So we plug that 74 in, we subtract our mean divided by standard deviation, and we get a value of a z-score of 1.167. Now if we do the same thing for maths, for English, we have got the average they're given us, and we've got the standard deviation. We plug in that 63, right? We want to compare that to the maths score. And so we plug in that 63, subtract the average, divide by the standard deviation, and what we get is a z-score of 1.625. Now, the English result in this case, the English result is better because the higher z-score shows that 63 is higher in comparison to the mean of mathematics. I hope this makes sense. I will do an example over here now. So this comes from your exercise. I think it's chapter, the first or second exercise, and it talks about an entrance test for a job. So the test has a mean score of 78 and standard deviation of 8. So that's what Ricardo sat, and then Corey sits a similar exam and scores 27. Alright, so they sat two separate exams. They were similar, but we want to figure out which one was who suited the job better, because there were different tests. They were similar, but slightly different. So what we want to do is calculate Ricardo's z-score. So I'm going to write Ricardo on this side and Corey on this side. What I do have is I've got his score, the average, and the standard deviation. Alright, and for Corey I've got the same thing. I've got his score, I've got his average, and his standard deviation. All I need to do is calculate the z-score for both of them, and I know the z-score is, for Ricardo, it's his score is 85 minus the average divided by the standard deviation. Same thing for Corey. I got his score, I'll subtract the average minus the standard deviation. Alright, and that's just the formula I got from the main formula to calculate the z-score. Okay, from there I've got a z-score is 85 minus 78 divided by 8, and on this side I've got 27 minus 18 divided by 6. What I then get is 1.5. That's for Corey, and for Ricardo 0.875. So who's the better candidate? In this case, Corey is the better candidate. With the z-score of 1.5 compared with 0.875 for Ricardo. I hope this is useful.